Welcome to the Digital Amateur Television Experimenters Night. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. Also participate in the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
All right, we're away, and apologies for that slight delay. We had some slight technical issues, but we have resolved those technical issues. So I've got the thumbs up from the producer next door, so that's good. Now, welcome Murray VK7ZMS.
Thank you.
How you going?
Good. Good.
Excellent, excellent. So Murray's in the studio because he is been doing some experimenting.
Experimenting with some junk that you acquired a few weeks ago.
It's not junk. It's not
junk.
Come on,
it's junk.
Come on.
Justin did a bit of a dumpster dive, came back with some gear. We pulled it apart and recovered some equipment out of it. And one of the things we pulled out was some stepper motors, which looked surprisingly like ordinary stepper motors, and we thought we can use those for all sorts of projects. The only thing is, they only had 3 wires connected to them, and I thought, oh well, you know, they probably only used 3 wires in the application for some reason. Had a look, the plug had four pins on it. I thought, that looks like it's probably a bipolar stepper motor, 2-phase bipolar stepper motor.
Yep.
Surely we can drive that. Took it home, had a little bit of a look, hooked it up to some H bridges, and yeah, nothing. It just went back and forth and buzzed. I'm like, oh, that's that's not good. Had a bit of a look. I thought, what's underneath the blue wrapper? Pulled the blue wrapper off, and there was nothing more than a heat cutout, which you can see on the side, on the right hand side there. That little thing's just a little device to stop it overheating.
Yeah. Okay.
So did a little bit more research, and I'm like, I don't know what the go is with this, but surely the internet can give us everything. Now,
Of course.
just as a bit of background for those who are not familiar with stepper motors, there's 2 main types of stepper motors that are used, certainly in a hobby scenario, and they're bipolar and unipolar stepper motors. A couple of diagrams on the left for the bipolar, and they're just basically a 2-phase motor, and you can control those. In the bottom picture, you can see you know, the fixed magnet north south, and you magnetise either side to spin it round. The next step, of course, you go either to the left or the right, which gives you your direction and which it spins. You can do, you know, the micro steps by doing, you know, them both the same, or
So
both.
that's changing the polarity on either of those to get them to go in the direction.
Yeah, and so if you wanted to turn clockwise, 2A would be purple in that picture.
Yep.
And if you want them to, and 1A would be red. If you want to go halfway, you make them both purple and it sits in the middle.
Yeah. Okay.
And then if you wanted to go a quarter of the way, well, you put different amount of current onto each of them.
Cool. Okay.
The bipolar, the unipolar is quite similar, except that you've got sort of like a centre pin, which is always positive, and then you basically just drop those pins low.
Yeah.
Yeah, so unipolar usually spins faster, doesn't have as much holding force.
And is usually less of a step. Is that correct?
No, they're quite distinct steps.
Like you get 1.8 degrees out of a unipolar, but you can't get that out of a bipolar. Is that correct?
No, you can, no.
You get 1.8?
Yeah, absolutely.
Okay.
200 steps per most of your cheap hobby ones are 200 steps.
Okay.
Yeah.
Okay.
For sure.
Cool.
For sure. So I was expecting it to be one of these, but I didn't have enough pins. I mean, a unipolar's, the basic one's either 6 or 5 pins.
Yeah.
The bipolar's a minimum of 4 pins, and if you've got more phases there, so it can have 6 pins. There's no real limit on that, just depending on how many steps you want and all that sort of stuff.
Yeah. Okay.
So I thought, that's a bit odd. So I did a bit more research.
Okay.
And what I found on the manufacturer's website, and I should hasten that there's no reference to this part number online.
Right. Of course.
And I suspect it was probably custom made with that cutout for that particular application, and they made a few thousand of them, or you know, and you can probably order the part number if you know what it is as a spare for that, but not on the public website.
Yeah, not in their catalogue.
However, what I did discover is the KT42, and it's clearly labelled as the part number starts with a KT42, so I thought, well, this is a good start. I also noticed that the pinout over in the bottom right hand corner there, the pinout is exactly the same as what we had on the motor. I'm like, we're on a winner here. Oh look, there's the steps there. Easy. I can make that work.
Winner, chicken dinner.
That's it. I thought it's just a matter of me programming highs and lows out of an Arduino. And hang on a second, it's not actually highs and lows. It's positive, negative, and nothing. It's 3 phases that we need for each of these things, 3 states.
Okay.
And then I went, let's have a look at that pattern. What do we see with that pattern? Oh, I've got these out of order.
Yeah. Yep.
If we put that pattern and over a standard 3-phase AC 3-phase signal, and we line up the phases there, we can see the steps line up exactly with those sequence.
Spot on.
So in fact, it's an AC motor, and they're like, we're just driving this really slow square wave AC.
Yeah.
At this point, I realised it probably wasn't that useful a stepper motor for any hobby applications, because it has 6 individual steps, and if you want it to go forward and then back from a particular step, you've got to write code that actually knows what step the last one was.
Yeah.
So I kind of lost interest a little bit at that point.
Okay.
I thought, I'll just download. There must be an Arduino library. There's an Arduino library for everything. No. There's nothing. I looked around. I couldn't find anything that even looked like it might be close. Okay. Lots of people went 3-phase, but they're like 3-phase bipolar and 3-phase
unipolar,
not 3-phase star wound. Right? This is like a 3-phase star that you would see in an alternator in a car, or
a star motor.
Or
AC
motor. Yeah, that's right. So it's a fixed magnet version of this, as opposed to a full induction. Yeah. So here's the circuit that I use, because I thought if I need to get positive and negative, I can do that with H bridges. And I can get off, but I can only use 1 pin out of each side of the H bridge because they swap. So I actually needed 3 of them, and these ones that are here are dual ones. And so I used 2 out of one and 1 out of the other, and that way I can get positive, 0, and negative. And that worked. And if you plug in our test unit over there.
If we go to, let me do the snazzy switching here, and go to here. Cool.
Plug some power in.
I will switch it on. Ooh.
And you'll see the unit in action there. It's just a small routine. It's just an Arduino Nano. and it's just stepping at different speeds just to
You can see
just
the
to
torque there
demonstrate.
because it's slowly turning itself around.
Yeah, so one thing, I got this to work and counted the steps, and there was 96 steps, and then I realised on that original documentation it did say 3.75 degrees, so
Okay.
that could have been a clue to start with. So backtrack a bit there.
Okay.
Anyway, so that's the device working, and yeah. So if we're going in one direction, it's good. It goes the other direction if you reverse the
Which you did.
yeah. So that's all good.
So Murray, just go through what we're looking at here because you've got the diagram. This bit here.
So there's an Arduino Nano sitting on a shield there just to give a whole heap of output pins.
Oh, okay. So that's a breakout type shield.
Yeah, so basically every pin comes out and beside it's positive and negative.
Okay.
So that you can just, because
Okay.
lots of things, you might be able to zoom in on that
Well, we can.
if we move it. Yeah,
And let's do. Oh.
bit of focus. So you can see each signal pin has
Oh.
a ground and a voltage. And,
Right.
if you want to run a pot into it, you're always going to need that. There's lots of things where you need to break out ground and voltage
Yep.
as well as that. So that's all that board does.
Nice.
I just bought a few of those online. They're like $4 or something.
Yep. Okay.
And that
And that runs off of 5 volts.
yeah, that's just a 5-volt nano.
Okay. So we then go to, these are connected to the, let's zoom out here a little bit.
So these are just a 298N H bridge, which again is far cheaper to buy online as a little unit with things on it than actually make them yourself. And the screw connectors are all there. You just it's like Lego, put it together.
Okay.
So yeah, nothing complicated at all.
Cool.
But you do have to write code to step it in the correct sequence because there is no library.
Yep. Okay.
You might want to probably unconnect that because I think it draws a bit much current for the H bridges. They overheat after a while. No.
Yeah, they do get hot.
Yeah.
They do get hot. Okay. I'm unplugging now.
Or perhaps it's a 5-volt motor and I'm driving on a 12 volts. Don't know. Hadn't got that far.
So
yeah,
that's what you're looking at.
that's the circuit. So basically, you've got to drive this sequence in the bottom left-hand corner. As you step through, you've got 6 steps that repeat one after the other,
Yep.
and you need to be able to turn those things up and down. Now, obviously, for every positive and negative on there, there's 2 for each step. You've got a different pin that needs to go either high and or low on the.
Yep.
Well, you've actually got 4 pins that need to go low and 2 that need to go high on the.
And to get it to go in one direction, you do 1, 2, 3, 4, 5, 6,
Yes.
and then to get it to go in the reverse direction, you go 6, 5, 4, 3, 2, 1.
No. You change the phases around.
Oh, okay. Righto. No, which is that. Now that's different to the unipolar, the way you drive a unipolar.
Oh, absolutely. Yeah.
Yeah.
This is just an AC motor.
Yeah.
A fixed magnet AC motor.
Yeah. Okay.
Yeah. So I wrote some code for it, and when you're writing repetitive code, well, that's a bit blurry.
Yeah. No, that's it. Doesn't come out. It comes out actually better on with what we're going to the
Cool.
stream.
So
it's just the monitor.
so this is just a screenshot of Excel,
Yep.
and just because I need to visualize stuff, I color coded it.
Okay.
And it's really a copy paste, change one field, and then use the concatenate command to create the code,
Okay.
which then repeats over and over.
Okay.
So once you've got that, you just put that into the loop, and away it goes.
Cool.
Code looks a bit like that if you're interested, but there's nothing fabulous about the code.
Okay.
It's just pushing through those steps.
Okay.
So yeah, if you want something with a very precise rev, which is what these things were designed, the initial application.
That's well and true.
They're a really good motor, I think. But for a hobby motor where you want to turn something backwards and forwards, or run a rotator or something, it's like
Yeah. Might not be the
I
solution.
think for the $17 that it costs you to go and buy the equivalent bipolar 2-phase,
Yep.
probably not worth the mucking around. Given you can download a library and then you just tell it 4 steps right, 2 steps left, and there's 4 lines of code instead of all this rubbish.
Yeah. Okay.
I mean, you can drive the others like this as well. You just got to write the code for it. There's no point. There's just no point. You use a library.
But and you mentioned earlier, basically this being really an AC motor, a 3-phase AC motor, means you could actually drive it with 3-phase.
Absolutely.
Low voltage 3-phase. So.
Yep. And if we had 3-phase here and a 3-phase transformer, we could hook that up. We wouldn't be able to change the speed of it, of course.
No.
It would just be
at 50 hertz.
Yeah.
So yeah.
Correct.
Oh no, cool.
Which would be a lot slower than a normal Starman induction motor, which would actually only have 3 of those windings.
Correct.
Right, because there's lots and lots in there because it's a stepper motor.
Yep. Yeah. In fact, it's a thing of beauty when you open up a stepper motor, because I would love to see the machine that actually winds those fields.
Well, it'd be interesting to see actually what's in that one.
So
yeah. Anyway, so that's my
that is fantastic.
that's my experiment for the week.
And can I ask a question? How long did it take you to get to this point? Like, how many hours did you spend on this? Getting to this point.
I think once I got to this point, I'm like, aha. Not that long.
Right.
Not that long. There was a fair bit of looking around on Google whilst watching TV and stuff.
Right.
But
of course.
Once I found that, I'm like, here we go. I can do that. And so
excellent.
Excel to the rescue, and my favourite command, concatenate, and bingo.
Bob's your uncle.
Just copied and pasted into the Arduino ID, and
excellent.
It pretty much ran straight away.
I'm incredibly impressed. Oh. This is fantastic, and you've actually you've used a piece of equipment that we've actually removed and dumpster dived for. So I'm even more impressed.
So yeah, they're usable. We've worked out how to make them work.
That is fantastic. Now, there is another device out there, I understand, that a tracker, Tricky's tracker.
Yes. It's a marvellous device. Shall
we do a reset in the studio, and we'll get Tricky's tracker into the studio.
If he's listening, but
calling VK7ZBX. We'll just take a short break, and we'll be right back. Okay, this is VK7HXT, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV experimenters night. We're just setting up. Mr. Tricky here. It's Tricky's tracker. Do you need to plug it in somewhere?
Yeah.
Probably over there is the easiest thing.
Cool. You just need to try and find a satellite that's going to be coming up soonish.
Oh, okay. Cool. Now. Oh, pardon.
Probably be doing awful things to the audio.
Yeah, it probably is. Well, you're getting a very visual effect. What I will do here is that little thing that you heard just then was this. So tricky. Describe what we're looking at. And welcome, Richard.
Oh, thank you very much, Justin. welcome. This is a device called a SATRAN, which is an ingenious product of a guy called Daniel. Let me just check so I can give him the credit. Daniel from Sweden, who's got a...
Sweden.
He calls himself the Swedish Inventor.
Excellent.
And while he was in lockdown, he decided that he wanted to play satellites and he wanted to build a tracker.
As you do.
And he's a very clever chap. So he's actually designed the whole thing from the ground up.
Okay.
And it's based on an ESP8266.
Okay. Yes.
Which is sort of in the back here.
In the back. Okay.
With a couple of little stepper motor drivers, like sort of a custom made sort of printed circuit board that basically takes the modules.
Wow.
And it's...
Actually, just
Yeah.
just turn that around.
I don't know whether you can...
We'll go back to here. That's it, and I'll come up a bit. So that's the ESP module over here,
Yeah, and the two stepper motor
and
drivers.
then
over
these
there.
two little heat sinks here.
And you can see down the bottom there's the limit switch. Oh, hang on, up there. I'll move. It's all right. So that's the little limit switch there for the azimuth drive.
Okay.
And then let me see if we turn it around.
There's
It's
a
all
stepper motor there.
Yeah, there's. It's a bit hard to tell, but there's a limit switch.
There's a limit switch just there.
Just there, yeah.
Okay.
So it's quite simple to calibrate the thing. You just turn it around so that it's just off one of the limit switches.
Yep. Okay.
And when it turns on, it just basically, when you start off from afresh, it basically creates a little access point that you join,
Okay.
and you join with your laptop.
Okay.
And it comes up with a little web page. You put in the wireless SSID that you want to connect to, and
Okay.
it's WPA2 key.
Yep.
It'll reboot and it'll join that network, so then you go back and join the network with your laptop.
Okay.
Go to the IP address, and it comes up with like a little interface.
So it creates its own little access point.
Yeah.
I love it.
10.1.2.
Just like a GoPro does.
I love it. I love it.
And oh, there it is. So that's...
Now, just as a matter of interest, have you got what have you got in the way of? Is that? Oh, that's a HDMI. Yeah. Okay. No, sorry. I could plug in, but it's a display port that I'm talking about.
So that gives you like an interface. I don't know whether we can see that.
Yeah. Yep.
Probably,
No. Go to here, and I'll go up a little bit here, and across, and do a quick focus. Wrong way. There we go. SATRAN rotator.
So that just gives you basically the ability to drive the thing, and when it does its calibration, it basically ends up 0 degrees
Okay.
and north.
Okay.
So you've obviously got to orientate the thing correctly.
Yep. Yeah.
But
Okay.
then it'll drive from
Alright.
sort of minus 10
Okay.
degrees to 90 degrees and 0 to 360.
I love it.
So then you download the SATRAN app, and it'll allow you to select from Australian satellites.
Okay.
You put in your latitude and
So
longitude.
who came up with all of this as well?
This guy, Daniel. It's like he wrote the app, he designed the bits. It's like...
I'm very impressed.
And he sort of like runs the shop that sells all the bits.
Okay.
So like I was fairly fortunate. Ken VK7KRJ very kindly printed the bits for me because he was pretty excited about the whole thing.
Okay.
So he printed all the bits. It's actually pretty funny. He thought it was quite funny. There's quite a different number of different colours in it. It's quite interesting.
Right.
Very unique. So then I bought the kit from Daniel. I think it was €100, which is for the circuit board and the software already loaded.
Okay.
The two stepper motor controller.
Yep.
Limit switches. The axle and quite like enough screws, and it's really meticulously put together.
Okay.
The screws you need, 9 of these screws, so it comes in a little plastic bag, and it comes with 2 extra. Each bag
Okay.
had 2 extra.
Okay.
And it was really quite a delightful kit. And look, it works really quite
And
well.
and it all went together really seamlessly. Like
Yeah,
it all.
I did have a bit of a moment where I thought, it's not working properly, but then I had a small moment where I assumed that the antenna was pointing out this way, but of course the antenna is actually sitting flat.
Yeah. Okay. Okay.
So, and this is the front. So that's minus 10 degrees that way, and the thing can actually pivot all the way over to there
Yeah.
to
Okay.
point straight up.
Okay.
So, but look at you actually get a cover too that goes over there and covers the whole thing. But so yeah, look, it's a pretty cool little thing.
It's
Look, again, it's you know, it's hardly a high precisionally machined thing, but you know, for what it is, it works a treat.
well and truly.
I think too, having a little bit of movement here and there makes it easy to assemble. Whereas if something was
It was tight. It could be, yeah.
like, I'd hate to be assembling that slew drive. The tolerances in that would be
Scary.
yeah.
Well and truly. So, excellent. So, can you actually give us a demonstration? Or
Well, look, let me just have a quick look.
There's
We'll
one I've
find out
prepared
if there's
earlier,
a satellite that's coming up.
I recognise that. Cheap predict. Yes.
So 2016 is AO85. So if we go deactivate,
At
search for AO85.
2016 in 10 minutes' time. So, Richard's.
There doesn't appear to be an AO85.
Hmm.
Oh, spotted the immediate flaw. No, it appears that I can't. However,
Is there a test function?
in lieu of a demonstration, we can basically go turn it round to 90 degrees and turn it up to 45 degrees.
Next key. Oh, there you go. You're definitely hearing that.
Yeah.
Oh, look at this.
I think a lot of that resonance and that noise would probably be reduced once it's got a bit of load. I think if you put an antenna on it
Yeah, okay.
and had a little bit of preload, perhaps either at the front or the back, I think it would probably reduce a lot of that sort of resonancy.
And what sort of specs are we talking about from the point of view of how much weight and that sort of thing? Have we got an idea?
I don't know whether he actually specified a figure, but I think you just got to be a bit realistic. And look, I think those elk or arrow sort of type antennas, and like we discussed, they're designed to be handheld. Maybe you could try that, because I think the 3D printed stuff's pretty deceptive how tough it is.
Yeah.
But even if you had to move it and maybe help balance it a bit more.
And counterweight it or something.
Yeah. But I think for a dual band thing, for like doing FM satellites, and it'd be ISS weather satellites, you know.
Yep. Yeah.
But I think it's probably a good.
Or even patch antennas, and you could just put the patch on top.
That's right. Exactly right. But,
that is fantastic.
yeah.
And how sort of long did we take to print things? Did we get a bit of an idea from Ken?
I think Ken said about 6 to 8 hours to print everything.
Okay.
And there was a few little bits that he said were a little bit tricky. There's a bit that's in the end of the. See that bit there where the end of the board is? There's like a little bearing that goes in the end of that burn drive that he said was a bit sort of tricky to print.
Yep.
And he's also printed a couple of extra bits. Some guys on the side have developed a bit that screws onto the bottom,
Right.
that sits on a tripod, so you've got a 38mm mount.
Yeah.
But he's designed it really cleverly. The hole on the side here, it's got a hole on the side here, and the size of the hole is specified by fitting a BNC connector through it.
Oh, okay.
So the idea is that the antenna cables come off the antenna and go into there, then come through the centre.
At the tripod. Yeah.
So then you don't have cables sort of getting wound up.
Okay.
So I think that's probably a good idea.
So what's the bottom look like? Oh, very nice.
So that those screws there, the screws on the top of that obviously once you put the top on, they actually control the preload on the. Because there's basically 12 little holes in there that have each got a bearing in it with a bit of grease.
Okay.
And you just basically preload that down till it spins quite nicely.
Okay.
So, it's...
He's thought about it. He's well and truly thought about it.
It's really good. So, satran.io.
Satran.io. Well, we'll put that in the write-up for the
But it's
article.
a really good bit of kit.
So, and there you go.
There's a little forum on there, and there's quite a few of them been sort of built, and I think... I believe he's looking at an improved model, but a more heavy duty model. And he's talking about, that's the problem. If you build something like this, how tough do you build it?
Well and truly.
all the way.
Mind you, I have seen 3D printed modules that have bearings actually in them. They print them so you can put a bearing in
That's
them
right.
and all sorts
And I
of
think
stuff,
too,
so-
this is a piece of Brooker rod.
Yep.
So the dimension of that, perhaps that's printed exactly to 8mm, and a
Yeah.
bit of Brooker rod's
Yep.
0.3 under. So
Yep. But then you can put a shim in there or whatever.
that's
you know,
right. But I think
that's-
your idea, if you were handy at 3D modelling, which I'm certainly not at this point, but yeah, you could print your own little sort of bearing caps to press a little ball bearing into, and
Well and truly.
I think that's getting towards maybe over the top for this side. Maybe if you went to a bigger
Yeah, more
device,
heavy duty.
bigger
Yeah, yeah.
stepper motors and stuff like.
But this, like, Satnogs is the other one, because I know Scott,
Yeah,
LXX, went down that path, and Satnogs is a worldwide group that was specifically to print this sort of thing, to do satellite tracking and then upload what they receive into a central
database, which was really cool.
So
I think Scott printed a couple of those. I think they
Yeah.
went pretty well.
no, they did, and then of course Julie and Joe and Julie,
They do
their version of it,
SAC
which
something SAC.
yeah, the school's
SACnet.
amateur radio, SACnet, SARCnet, SARCnet, the school's amateur radio club. They do a version as well, but theirs is actually it's a metal version. There aren't too many 3D
I've actually got
printed.
sort of the bits to build one of those with a little tooth belt. I think Mark from Mini Kits came up with because instead of using the chain, because the chain and the sprockets were too hard to get.
Correct. And also there was a bit of play in that because I saw their prototype because they did a talk at Gibbs Tech one year, and their prototype, and I went up to it and sort of went, okay, there's a bit of play there.
Yeah, I think just an inherent thing with chain, with sort of roller chain, but the little tooth belts I bought, one to fit over the 25mm tube, and I think you could have quite easily enough strength to drive a 2 metre cross Yagi and a 70cm cross Yagi for sure. You probably maybe want to look at having a short stub through the rotator and then put like maybe a piece of solid fiberglass through to have the insulation to not mess up your pattern of the Yagis. But that's on the to build list as well. But this guy pushed in. So.
I love it. Okay, now stay tuned because our and now hang on, we've got Harry online, we've got Pranky74, so 1974, hello, Ham Radio DX, we've got Hayden in the club rooms giving us a bit of a signal report there, and Ben who's had to disappear, but and Andrew Elwell, so hello Andrew.
Hello Andrew.
The ESP8266 ESP32 creating its own access point for configuration is a fairly standard trick. So I've been blatting out a bunch of Tasmodo firmware onto devices recently. So there you go. So thank you Andrew. So good stuff. Now, last week we tried to play a drone video. Now, what we've actually done is we've recoded that particular. So we've recoded a new video. It's actually a new video that we are going to play here. Now, I better not do that, but I'll do that. Yeah, or we'll get a really nasty little. Now, if I drag this across to here, woohoo, and push the big button marked idiot and see what comes out. So, now this is a drone video of the Queen's Domain taken by Tony VK7VKT on the I think on the weekend. This is a bit of tower inspection.
Good work.
So there's our 6 metre halo, and then our 2 metre and 70 centimetre, and then that's looking across to Mount Wellington, and Lena Valley and West Hobart, and coming around to the CBD here. So that's the CBD of Hobart. There's the Derwent River.
It's a good line of sight there.
Oh, definitely. In fact, if you could take the drone up, you could do a 630 metre
Yeah.
full wave antenna, which would be quite good, except it's 630 metres, so it's actually above the 500 metre mark. But anyway, there's the Tasman Bridge.
500 Microsoft meters, sure.
That's it. Yeah, that's it. Across to the Gilston Bay and all of that sort of
Tone Hill, is that in the Tone Hill?
yeah, Self's Point sticking out there. There's Mount Direction right in front of us, right there. Back to Lutana and off to Glenorchy and everywhere. And Derwent Park back round, and here's Mount Wellington.
That's really good.
So he's done a
That's in 4K too, I think, isn't it?
360. It is actually. It's in 4K, although we're not broadcasting in 4K. So so it's going to be losing a little bit there. And then he comes down. We do a little bit more inspection here. And I have to say, I'm pretty impressed with Tony's grasp of the drone control here.
Yeah.
Is pretty impressive.
Smooth.
Pretty impressive.
Yeah.
So this is looking at the domain compound, and then he does a bit of inspection of the broadband HF marine HF antenna, which is Tas Maritime Radio. So this is one of their emergency antennas. I think he does a swing around here. And that's the top of the Queen's Domain, and we come back around to, here we go, and here's the maritime broadband antenna from Tas Maritime Radio that they use every so often. And I think he goes up to the feed point here, and this tower is, toying with danger here.
It doesn't go all dark real quick.
And suddenly find you're on the ground.
Yeah.
There you go. There's the feed point that's for that particular antenna. I think he even goes. He's dicing with danger here.
Yeah.
Dicing with danger. But you can sort of see for an inspection point of view. You can go right up to the feed point if you game and have a look and do some inspections of waterproofing and all sorts of stuff. And oh, here we go.
Pretty nimble flying.
I'm a little bit disappointed though, Tony, if you are listening. The last one you supplied, it did actually have you in it, whereas you've avoided this particular one, I think. So yeah, here we go. We head across to
our tower.
with a tower laying there, and then I think we zoom around, and you've got Tas Maritime Radio facility here, and then we go over to our other tower here, hoping that no one keys up the 6 metre horizontally polarised antenna. Or the 2 metre antenna for that matter, because that's on the top of this particular tower. Now there's the 6 metre dipole. That is horizontally polarised.
Is that the one with the dodgy coaxial?
Yeah.
No.
Yeah. That's no, that's not. No, this one isn't. This one's actually got a decent piece of coaxial.
That's got the LMR.
Well and truly.
Yeah.
Well and truly. The one that we just the bit of LMR that goes through the
comes through here.
conduit. Yes.
Yep.
That's it there actually. So yeah, a bit of a feed point inspection here, which is great. Really good. Turn around, you can see the top of Tas Maritime there. Oh, we go across and now this is quite good because this is actually the antenna that we're transmitting the ATV signal on, the 445.5 megahertz DVB-T signal. It's on this cloverleaf just here, which Richard actually mounted on the roof. So Richard knows and loves this particular antenna. So that's the cloverleaf, and then we back. I think now there's another antenna there, and I'm actually not sure what that is. It looks
Mystery antenna.
it actually looks a bit
A
like
dual band mobile.
CB antenna, but anyway, with a centre loading coil in it. Mobile whip, yeah. So anyway, that's the drone video. So yeah, okay, Ben, I understand. Steve, can you close that door? Because we're getting a lot of noise from next door. Oops. I think that was the power supply that just dropped out of the thing over there. But anyway, so that's the drone footage from the Queen's Domain. So there you go. So what we might do, we'll just do a quick reset. I've got Harry and Xavier coming in with their freshly built Moxon VHF UHF antenna. So we talked about the way to guide the antenna. We now look at the antenna.
I've been trying to sell it to them.
So, oh, very good.
Thanks, Justin.
Cheers, Richard. So, calling Harry and Xavier into the studio, and we'll have a quick look at the antenna that we put together last week, and now, and then we'll have a look at a quick look at the latest DUBUS magazine that came in a couple of days ago into the mailbox. So yeah. Now. Okay. Come in. I can't get all three of you in at the same time, but we can do that.
The side.
We can do that. Yep, that's good. We can grab that in a sec. So no, come in. So what I will do is the cam 1. Oh yeah, that's not good, is it? We need to zoom out there. Oh, zoom in there, zoom out there.
Yeah, you can leave me out, it's fine.
No, what I can do here is oh, hang on. There we go. Now I'll get you in focus. That's probably better. Now there you go. Now welcome to. We've got Harry on the left. Wave Harry. Who is VK7HXT, and we've got Xavier VK7XHJ. Hello and welcome.
Thank you.
Now this is the first time you've been in the studio, isn't it?
Yes, it is. For both of us, actually.
Excellent. Excellent.
And for new licensed hands, well, I think we're doing all right.
You're doing exceptionally well. So, and I hear you on the repeaters. I hear you on DMR. I see you on DMR. It's just outrageous. So I think that's great.
Awesome.
It's good. And you're having fun. That's the main point.
Yeah, I'm absolutely enjoying it actually. It's allowing me to learn a whole lot more in the electrical side, and also the radiation field side as well. And making sure, also not only that, but also allowing me to explore opportunities in the electronic side as well, which is absolutely marvellous.
Okay. And have you got a particular sort of interest you're pursuing at the moment? Like satellites. Oh, good answer.
I would like to. I'm not sure about Xavier, but I would like to look at working into satellite work.
Okay.
I've seen a lot of videos on YouTube of people doing it. It is hard work. I know there is a lot of hard work to it.
Yep. Okay.
But the rewarding thing I find is you get to make a contact on air, and as far as I can see, your voice gets to go out of space and return back.
Well and truly, that's fantastic, and it is a real challenge to get things working. But when you get things working, it's a really satisfying exercise. No, good stuff. So now we've been putting together, and I'll.
I think you're still on cam.
Oh yeah, no, that's all right. Can you hold that, Xavier? Because what we actually have here is Ben VK7. Actually, what I'll get you to do, just put that and leave it on there, because I just want to point out a few little things here. Now, we'll go here. No, actually, we'll go back there because that's better. Now, so this is the VK7BEN came up with a kit which included the aluminium welding rod. So the aluminium, these are aluminium welding rods of 3, I think they're 3.2 mil, and there are some connectors and some coax and some really nice little saddles here that screw onto a wooden boom, a pine boom, so it makes it really easy to screw into. And it's a multi-band Yagi for 2 and 70. So these are all tuned for 2 and 70 centimeters. But the key thing is the driven element, which is the different. This is what makes it a Moxon antenna. So Les Moxon is the guy that actually designed this antenna. The driven element is actually. This is one side of the driven element. Sorry, this is one side of the driven element that goes to here, and there's a gap in here, in this, and this is a little raw plug. So this is a little plastic raw plug that you use in masonry walls, and then there is the other side of the dipole is exactly the same, and it goes to a gap on this side, and then the bottom here is a straight bit of aluminium welding rod that goes round and matches the shape of this driven element, these two driven elements. And the way that you actually tune it, the gap inside here, what we did was put a SWR meter on this, and then slowly get the SWR down. And the way we did that was we actually expanded the gap in each side of here until we got the SWR down to an acceptable level for 2 meters, and then on 70 centimeters, we then tested it on 70 centimeters. Now, on 70 centimeters, the SWR was perfect. So on 2 meters, it was about 1.3 to 1, which is acceptable. It's under 1.5 to 1. But on 70 centimeters, it's 1 to 1. So really, really nice little 2 and 70 centimeter directional antenna. So yeah, that's what we came up with, and Ben donated it to Xav here. So we got it all working. The next thing is we head out and we start to look for some satellites, and then the next step is we actually try and work them. And as Harry put earlier, that needs a little bit of effort put into it because it's not quite as easy as just going onto a repeater and going CQ. So, but it's eminently doable even with a handheld.
Yeah.
So yeah, that's the VK7BEN kit, Moxon VHF UHF Moxon kit. So yeah. Now, Xavier, what do you? And you're going to say satellites. I know this. What are you interested in right at the moment? What's the sort of thing you're pursuing in amateur radio at the moment? Satellites. Oh, there you go.
Although last night we did see one, but the antenna wasn't. It was downstairs, so.
Oh, okay.
Too far.
Okay. So you actually saw something go across?
Yeah. It just so happened it was just a little dot in the sky and it was going past, and oddly enough, it was going at the same speed as what we thought was a satellite. And,
yeah.
It just so happened we had the antenna downstairs, so it was a shame we weren't able to see if we could track it at the time. But eventually we'll put this to really good use and get some satellite work out of it.
Fantastic.
On the handheld, hopefully.
And it's good to see that sort of thing because it gives you an idea about the speed at which satellites move at.
Definitely.
So if you're tracking it in the sky, sometimes you'll see it, which is fantastic because you can point at it, but sometimes you won't be able to see it. So and it gives you an idea. So the tracking programs tell you, what the azimuth is. So what your the direction in 360 degrees that you've got to go, and then the elevation, which is the angle up in the sky that you've got to be pointing at. Yeah. So the little satellite tracker that Richard had here.
As he was talking about that here on air, I thought, well, maybe we should team up, have that mounted on the actual satellite tracker and see if we can get a good satellite contact, I reckon. Maybe the ISS, I reckon.
ISS, yeah, they run a repeater quite often on a 2 and 70, so
Yep.
2 up, 70 up, 2 down. So yeah, definitely.
Yeah,
So good stuff.
that's all good.
Fantastic. Well, thank you guys.
Thank you. Thank you
good.
everyone for letting us be on air for the first time.
Oh no, that's piece of cake, and I'm looking forward to seeing this in action. So
Yes, we'll have to video it in action and bring the video for you guys to watch it in action at one stage.
here, and we'll if you need any help, just yell out, and we'll give you a hand.
Thank you.
We'll give you a hand. So good stuff. All right. Good luck.
Thank you.
All right. We'll just do a quick reset. Another reset. We're doing a lot of resets tonight. And oh no, hang on. We've got Pranky 1974. I don't know whether you know. It's Julie, their mum here. Oh, there you go. Oh, very good indeed. So, woohoo, yahey to Harry and Xavier. And Ben, grin, try not to look the off-air TV. I fall for that every time. Okay. Andrew Elwell, nice design. Go to hold another building session. Oh, yeah, okay.
Oh,
well,
thank you.
there you go, Ben. And now there's a bit of an exchange going on, and there you go, Julie again. Proud of you both, Xavier and Harry. So there you go. So good work, guys.
Thank you.
And yeah, so good stuff. Thanks, Ben. Thanks, Andrew, and thanks, Anthony. VK7LAG's on there. So thanks to all of them. Wishing you luck.
Thank you.
Thank you.
Good stuff. All right, we'll just do a reset, and we'll do our final piece, and then we'll get into the club rooms. All right, thanks, guys.
Thank you.
Catch you around.
See ya.
Now let's do that, and we'll do. Alright, this is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night. And wow, what a what a huge night. So we'll finish off now with the latest copy of DUBUS Magazine. Now, for those who don't know, DUBUS Magazine is probably the VHF, UHF and microwave magazine for experimenters. Comes out of Germany. It is a bilingual magazine, so all the articles are in English and German, and it's comes out every couple of months, every quarter, 4 times a year. And then there is a Technics magazine as well, that is a combination of a number of technical articles that they produce in each year. So the big focus, new 1.3 gig Yagis, which have a very interesting driven element arrangement in them. So editorial, which you'd expect, there is the 1296 low noise Yagi with a bent dipole driven element, which is a bit of an interesting design. So it's got the parameters for putting it together and the segmentation. You can see here, here is the bent dipole. So here's the design. The arms of each side of the dipole, and this is square aluminium tube with insulators, and the actual driven element are these two wings that are actually bent backwards to give you some matching. All of the data. One of the things about DUBUS Magazine is it's always very heavy on the technical aspects of them. You can see this is the German version of that particular article. The applied conversion of segmented wires from NEC 2. So this is the modelling software for the 1296 Yagi elements. So this is how the actual conversion and modelling of them is done. And the relevant areas that are covered, as well as the plots, and then the actual physical antenna that they use after they have modelled it, and then the testing of the actual physical, the real antenna, and see whether it matches the modelled data. And you can see this is the test ranges that they've set up to do the radiation patterns, etc. And again, in German, that particular article. Environmental noise models and design of low noise antennas in the VHF to SHF bands. This is number 2, and very heavy on the maths in this particular article, and how they're actually doing it. Some interesting drawing on astronomy projects where they want really low noise environments. And the modelling and the results from those antennas. Now we keep going through. This is also where you've got things down at sub-zero temperatures when they're trying to get the noise floor to the lowest they can. So they cool things with liquid helium and all sorts of things in the astronomy game. In fact, Andrew would probably know about that. A 5-element OpDes Yagi for the 8-meter band, and the real-world translation from the software model. So this comes from Justin Johnson, who is G0KSC. An article on that particular type of Yagi for 8 meters. And the design, the German. Now we go through. Now here we go. 10 gig terrestrial with Q65 part 2. So the first one was in the previous magazine. And tropoducting over 1960 kilometres between Tasmania and New Zealand by one Mr. Rex VK7MO. So there's a little article in here about. Now this was when Q65 was in its infancy and being tested. So a little article about that. Sporadic E summary for 2020 on 2 meters. Very Europe focused in this particular magazine, but there are segments in here for other the US and also other areas. Here we go. This is Australia, so it does include Australia, and also here we go, VK7HH, VK4NE on Whisper over in fact Christmas Day. So there you go. And some of the other the Australian to New Zealand contacts that were going on. Here we go, here's Tasmania. So who was that? VK7DC, so Dave Cleland in that particular case. Some analysis of the sporadic E openings. Then Microwave Europe, Spain and Portugal. So the experimentation that's going on, it's experimentation in the US. And this also has the 241 gigahertz record set by Mr. Kuhn himself. So yeah, Microwave Japan, the solar cycle, number 25. Some other news in here. There's the Technics magazine, the advertisement for Technics magazine, and some silent keys, unfortunately, and then how you order DUBUS, and some advertising as well. So really cram-packed little magazine, and if you're into VHF, UHF and microwave experimentation, it is definitely the magazine of choice. You can Alan Devlin, VK3XPD, is the Australian contact who organises the DUBUS magazine, and then it's mailed directly to you from Germany every quarter. So yeah, well worth it, and lots of people who go along to Gips Tech subscribe to DUBUS magazine because it is considered to be the preeminent VHF, UHF and microwave experimentation book. So yeah. So now just checking out. Oh no, okay, that's all right. There's a bit of a conversation going on between Ben and Anthony. So now, just a quick reminder. Our next it is next week. The presentation night, Reast presentation night for August is coming up. It is at yes, I'm just double checking. It is next week. Now, focus is on contesting. VK7GN Martin is doing HF contesting, presentation on HF contesting, and VK7ZBX, our own Richard, is doing one on VHF, UHF contesting. Now, this is to get you all excited about the Remembrance Day contest, and getting some skills, knowledge and experience around contesting in the Remembrance Day contest. So please come along. 7:30 Queen's Domain Club Rooms. It will be streamed, so you'll be able to watch it on the stream. Our September, which is Wednesday the 1st of September, is the Tas Government Radio Network, P25 Emergency Services Network, which is going into Tasmania as we speak, and a presentation on that particular network by Andrew VK7 Alpha Juliet. And our October is Sunday the 3rd of October, so this is actually a Sunday one. We're having a barbecue, and then we're having a little presentation all about military radios with Peter Dodd, VK7 KPC, who's coming down from Evandale, and also Kim Briggs, VK7KB, who's bringing along a whole selection of military radios, and they'll actually have them set up. One of the reasons we're doing it on a Sunday is so that they can set up antennas, and we can actually demonstrate these particular rigs and the antennas that the innovative antennas that go with it. So that's what that's all about. For our RF viewers tonight, we have a few videos, a couple of videos on the best ham cartoons, part 1 and part 2, which is absolutely, that's a bit of a scream by a couple of hams, and then the history of the ham Radio Shack by the same two, and then there is another one on a visit to Bletchley Park. So that's quite a fascinating little video there. So we'll get underway with those for our RF viewers. So this is VK7 OTC. Thank you to all of those people who contributed on the stream. Fantastic. And also any viewers who are out there who didn't call in or didn't come up on the stream, please think about coming up and letting us know, and we'll get underway with our videos. This is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night. And we'll catch you in a fortnight's time after the presentation night. 73.